Alright, in this short video I'm going to go over a few of the questions from the week 3 discussion. The first one is number 2, find the point on the y-axis that is equidistant from the points negative 2, 0, and 3, 5. So let's get a visual here. Oops. So negative 2, 0 would be something like here, and 3, 5 something like here. Now, what we want to do is find the point that is equidistant so that D1 is equal to D2. So we want the distance from this point on the y-axis to be the same distance to the first point and the second point. So we want D1 to equal D2. Well, the distance of D1, well, we don't know what this point is, but we know that it's along the y-axis. So that means the x-coordinate is 0, and the y-coordinate is an unknown. Let's call it y. So to find that distance, we're going to find the difference of the x values, so 3 minus 0 squared plus the difference of the y's. We will say 5 minus y squared. And that has to equal the distance from the second point to that point on the y-axis. So we'll say the difference of the x's, negative 2 minus 0 squared plus the difference of the y's, 0 minus y squared. And that's the distance for D2. So let's go ahead and solve this equation here. So 3 minus 0 squared is going to be 9 plus, now 5 minus y squared is 5 minus y times 5 minus y. So multiply that out, we're going to get 25, I'll do it over here, 25 minus 5y minus 5y plus y squared. These middle terms combine. So 25 minus 10y plus y squared is equal to square root of, well, negative 2 minus 0 is negative 2. Negative 2 squared is going to be 4. And then 0 minus y is negative y. Negative y times negative y is positive y squared. Okay, so from here we can square both sides of this equation. So that'll remove the radical. So 9 plus 25 is 34. Minus 10y plus y squared equals 4 plus y squared. I can subtract y squared from both sides to get that to cancel, and then I'm going to subtract 34. We get negative 10y equals negative 30. Divide by negative 10, and we get a y value of 3. So this point here is going to be 0, 3. Moving on, find the domain of this function, h of x equals square root x squared minus 9x plus 20. Well, this is a radical function, so to find the domain of a radical function, we take the radicand, which is the expression underneath the radical, and that has to be greater than or equal to 0. Now, to solve this, why don't we go ahead and factor the trinomial on the left-hand side. We're going to have x minus 4, x minus 5. Now, what we're going to see here is that 4 and 5 will make this equation equal to 0. So we call these points the critical points for this expression. Now, what we want to do is, in each of these intervals, we want to determine if the interval is positive or negative. So let's take this expression, x squared minus 9x plus 20, and let's plug in some values. Well, a value over here that we can plug in that would be easy to work with is, how about 10? So 10 squared minus 9 times 10 plus 20, that's 100, minus 90, so 10 plus 20 is 30. So this is going to be positive over here. Let's pick a value in the middle. Not really anything very easy to work with. How about 4.5? So 4.5 squared minus 9 times 4.5 plus 20. We're going to get 20.25 minus 40.5 plus 20. And we get 40.25 minus 40.5. This is going to be equal to negative 0.25. So it doesn't matter what the value is, but what's important is that that is negative. And then let's pick a value for that third interval. I guess I did this a little bit backwards. I picked 10, and that's in this third interval. So now let's actually pick something that is over here. The easiest value to pick would be 0. So 0 squared minus 9 times 0 plus 20. Well, we get 0 plus 0 plus 20 is going to be 20, and that's positive. So from here, we saw that that one's positive, this one is negative, and this one, we get a positive value. Now, we want these values to be positive. We need this expression to be positive. And where is it positive? Well, it's going to be positive from negative infinity to 4, and then it's going to be positive again starting at 5 to infinity. So that is the domain here. A second way we can think about this is if we look at the graph. Now the graph of this is a parabola, crosses the x-axis, the graph of this expression right here, x squared minus 9x plus 20. It's going to be a parabola, and it's going to cross the x-axis at 4 and 5. Well, where is this positive? This is positive here because the curve is above the x-axis, and it's positive here. So that corresponds to the domain that we just found. And then this last one, find the domain of I of x equals 3 over square root 4 minus x. Now, we need this denominator. There's a couple of restrictions here. It cannot be 0 because we cannot divide by 0. And because we have a radical, the radicand must be positive. So normally we would say 4 minus x must be greater than or equal to 0. However, because this is in this radical is in the denominator, we're just going to say 4 minus x must be greater than 0, because that expression cannot equal 0, because while that would work for the radical, that would not work for the fraction. We cannot divide by 0. So solve this for x. We're going to have 4 greater than x. Sometimes people like to write this as x less than 4. If we think of this on a number line, we're going to say everything less than 4 is going to be our domain. So writing this in interval notation, we'd say negative infinity to 4. Or if we write this in set notation, we'd say all x such that x is less than 4. And that would be the domain.